Hey guys, welcome to the second part of Lesson 5, Lesson 5B. So last week in Lesson 5A, we talked about the counting half steps method of identifying intervals and their quality. And that method is always going to be there for you to fall back on, but if you're anything like me, you're busy people and you don't have time to always be counting all the way up to 11 half steps when you want to identify a major seventh. So this week we're going to be talking about the inverted intervals method for identifying interval quality. And that's going to make identifying the bigger intervals like fifths, sixths, and sevenths a lot quicker for you. So let's jump right into that. To invert an interval, take the bottom note and move it up one octave so that it becomes the top note. So in this example, A flat to F, A flat is our bottom note. So that's the one that we're going to want to move up one octave, like that. So we just found the higher version of A flat up here above the staff. So the original interval here is A flat to F, and our new inverted interval is F to A flat. Let's take a look at the number component of each of these intervals. So our original interval, A flat to F, is going to be a 1, 2, 3, 4, 5, 6, sixth. And then our new inverted interval, F to A flat, is a 1, 2, 3, third. In this example, our original interval is E to F. So to invert this interval, we want to take the bottom note and move it up one octave. So our bottom note here is E. So we want to find the higher version of E on this staff. And again, let's figure out the number component of these intervals. So our original interval, E to F, is going to be a 1, 2 second, and our inverted interval F to E is going to be a 1, 2, 3, 4, 5, 6, 7 seventh. Here's another example. Our original interval is D to G. So we're going to take our bottom note, which is D, and move it up one octave by finding the higher location of D on the staff. And then we'll find the number component of each of these. So our original interval D to G is a 1, 2, 3, 4, fourth. And our inverted interval G to D is a 1, 2, 3, 4, 5, fifth. Last example of this, our original interval is F to B. So then our inverted interval is going to be B to F because we're going to move this bottom note up to the top. Ta-da! And then we're going to count to find the number component of each of these. Our original interval F to B is 1, 2, 3, 4, a fourth. Our inverted interval B to F is going to be a 1, 2, 3, 4, 5, fifth. So there's actually a pattern to how the number components of the original and inverted intervals relate to each other. So whenever you invert a second, it becomes a seventh, and whenever you invert a seventh, it becomes a second. When you invert a third, it becomes a sixth, and when you invert a sixth, it becomes a third. And when you invert a fourth, it becomes a fifth, and of course a fifth becomes a fourth. A convenient way to remember these relationships is that the number component of the original interval plus the number component of the inverted interval will always equal 9. So 2 plus 7 equals 9. A second becomes a seventh when it's inverted. 3 plus 6 equals 9. A third becomes a sixth when it's inverted. And 4 plus 5 equals 9. A fourth becomes a fifth. So the next question is, how does the interval quality play into all of this? So using our old counting half steps method, let's figure out the quality of our original interval A flat to F and our inverted interval F to A flat. So first we're going to find A flat to F. So let's look at our keyboard. Here's A flat and here's F. And we're going to count our half steps. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 half steps from A flat to F. We're going to look over here at our chart. 9 half steps correlates to a major sixth. So we're going to go ahead and add in the quality here. So this is a major sixth. Now let's look at our inverted interval. So looking back at our keyboard, here's our F and here's the high A flat. So we're just going to count our half steps. 1, 2, 3. And 3 half steps correlates to a minor third. So we'll add our interval quality here. F to A flat is a minor third. So our original interval A flat to F was a major sixth, and our inverted interval F to A flat is a minor third. Let's do the same thing with this example. So our original interval is E to F. So here's E and here's F, and we count our half steps, and it's just 1, which is the same as a minor second. So we're going to add our interval quality there. Our inverted interval is F up to E. So here's F and here's E. And we're going to count our half steps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And 11 correlates to a major seventh. So we'll add our quality. So our original interval E to F was a minor second, and the inverted interval F to E was a major seventh. Our original interval here is D to G, and we count our half steps. 1, 2, 3, 4, 5. 5 half steps is the same as a perfect fourth. And our inverted interval is G to D. So counting half steps, 1, 2, 3, 4, 5, 6, 7. 7 half steps correlates to a perfect fifth. So our original interval D to G was a perfect fourth. And our inverted interval G to D was a perfect fifth. And finally, in this example, our original interval is F to B. Counting half steps, 1, 2, 3, 4, 5, 6 half steps is a tritone. So we're going to write that in. And we're going to leave the 4 but put it in parentheses, because it's always good to know that it's a tritone that's written like a fourth. The inverted interval is B to F. So counting half steps again, 1, 2, 3, 4, 5, 6. This one is also a tritone. And we're going to put the 5 in parentheses so that we know that it's a tritone that's written like a fifth. So our original interval, F to B, is a tritone written like a fourth. And our inverted interval, B to F, is a tritone written like a fifth. You may have noticed that there is a pattern for how the quality of the original interval relates to the quality of the inverted interval. So when you invert a major interval, it becomes a minor interval. Like in our first example, where we had a major sixth that was inverted and became a minor third. When you invert a minor interval, it becomes a major interval. This is like our second example where a minor second was inverted and it became a major seventh. When you invert a perfect interval, it remains a perfect interval. So this is like our third example where we had a perfect fourth that was inverted and became a perfect fifth. And finally, when you invert a tritone, it remains a tritone. So in our last example, we had a tritone that was written like a fourth, and it was inverted, and it became a tritone that was written like a fifth. Basically, what all of this means is that you only ever really need to count up to 6 half steps, which is the tritone number. Because anything bigger than that, you can just use the inverted version of the interval to find the quality. But let's take a look at the homework, handout 5B, and I can show you what I mean. Whenever you're identifying intervals, the first step is always going to be to find the number component of the interval. So when you do that and you find that you are dealing with a fifth, sixth, or seventh, that's going to be a little sign that tells you should think about using the inverted intervals method because it'll probably be faster than just counting all of those half steps. So part C on your handout 5B shows us how we can use the inverted interval method. So let's take a look at number 3. Our first step is going to be to name the 2 notes that were given. Then we need to actually invert the interval. And so to invert the interval, we move the bottom note, which is D, up 1 octave. And we'll write that that's D. And then the next step is to find the number component of each of these 2 intervals. So we'll count our lines and spaces. 1, 2, 3, 4, 5, 6, 7. So we know that this is some kind of seventh. And then over here, 1, 2, we know that this is some kind of second. We also could have figured out the number for the inverted interval by just figuring out how much more we need to get from 7 to 9, because a seventh is always going to invert into a second. So then, instead of trying to find the quality of this first interval, let's take the easy route and find the quality of the second interval. So our inverted interval is C sharp to D, and we'll count our half steps, just 1, and we know that 1 half step is a minor second. So we add in our quality there. And then to find the quality of our original interval, we know that when a major interval gets inverted, it becomes a minor interval. So since we found that our inverted interval, C sharp to D, is a minor second, that means that our original interval, D to C sharp, must be major. And in fact, it is a major seventh. Now let's take a look at number 9. So here we have E flat, D flat, and then we know that we're going to have to move the bottom note up, so we're going to have another E flat, and we're going to find the higher position of E flat on the staff, like that. And then let's find the number components of each of these. So let's do the easy way. We're going to look at the smaller one, 1, 2. So we know that our inverted interval is a second. And then if we say 9 minus 2 equals what? That's a seventh. So we know that our original interval must be a seventh, because a second is always going to invert to a seventh, and a seventh is always going to invert to a second. Then our next step is to find the quality of our inverted interval. So our inverted interval is D flat to E flat. And then we're going to count our half steps, 1, 2. And we know that 2 half steps is the same thing as a whole step, which is the same thing as a major second. So we'll write that in. And then we know that a minor interval, when it gets inverted, becomes a major interval. So given that our inverted interval, D flat to E flat, is a major second, that must mean that our original interval was a minor. So that's what it is. It's a minor seventh. And that's that. Let me know if you have any questions about this method. We're going to practice this method for the next couple weeks, but if you decide you hate it, you can always go back to just regular old counting all of the half steps. And be sure to look out for my video each week that's going to talk about inverting intervals and how that relates to solfege, because that's going to help with your ear training. Yay! So fun! Bye!